Today we're going to talk about high-res or Retina displays and how to create web pages such that photos, graphics, and text look good on those high-res displays. My name is Jim. I'm a web developer in Washington, D.C., and I teach front-end development. Today's big ideas. Big idea number one. High-res or Retina displays are here to stay. I'm going to talk about what they are. I'm going to talk about how they came to be. I'm going to talk about the future of high-resolution displays. Big idea number two. If you are designing web pages or developing web pages that might be seen on high-res displays, you don't have to worry about typography or CSS elements. Big idea number three. You do have to worry about images and graphics. In order to deal with that, you've got to double the size of images and graphics. I'm going to talk through what that means and how to work with that. Big idea number four, if you have vector graphics, you can use SVG or fonts to show vector graphics. These are ways that you can deal with high-res and Retina displays. I'm going to go through all these, explain what all these things mean. If you don't know what they are, that's fantastic. I'm going to explain them. If you have questions after I'm done, I'd be delighted to hear them. Okay, ready? Great. Big idea number one, high-res displays are here to stay. Let me walk you through the history of this. Let's go back 10 or so years ago, a little bit more, to monitors that look like this. We all had monitors that look like, I don't know, I had a monitor that looked like this. I don't know if you did. This is a delightful 17-inch CRT monitor. It's 17 inches because 17 inches is the measurement from diagonal to diagonal. That's how all monitors are measured, by the way, and TV screens. They measure the diagonal. What 17 inches diagonally means that it's about 10 inches tall and at about 13 inches wide. That's give or take what the measurement is there. Now, on any monitor, but especially on these old CRT monitors, they could only fit a certain number of dots per inch that they could display because the technology, the tube technology, only allowed a certain amount of resolution. A dot is sometimes called a pixel. A pixel is an individual unit of color that's displayed on a screen. Now, this particular example, this 17-inch monitor could display 1024 pixels horizontally and 768 pixels vertically. This was a standard that folks came to. They're those particular numbers because they're multiples of 2. And because this is what the technology could offer, that they could fit this many pixels into that size monitor. That's where we get 1024 by 768, which if you've been working on the web for a while or if you've been working on computers for a while, you probably recognize that measurement. If you take the number of pixels here and you divide it by the length, so if I take 1024 pixels and I divide it by 13.6 inches, say, then you're going to get about 72 pixels per inch. It's not exactly right, but it's about 72 pixels per inch. Now, that 72 pixels per inch measurement is recognizable to print designers because it matches the number of points per inch. Points is a unit of measurement in print. It's like picas. Points make up a pica. There's 72 points in an inch. Well, when the Macintosh first came out, Steve Jobs and company said, let's set up the unit of measurement for our monitors to be equal to the unit of measurement for print. So let's make 72 points per inch, like 72 pixels per inch, like 72 points per inch. Microsoft decided to go a slightly different way, and they went 96 pixels per inch. My point being that monitors of this era were in the neighborhood of 72 to 96 pixels per inch. That's what could actually be displayed on the glass, on the inside of the glass of the monitor itself. Now, this has not changed a whole lot in the years that have ensued, especially with desktop and laptop machines. Let's take a comparison to a 27-inch iMac that came out a couple years ago. This is top of the line, beautiful computer. Its pixels per inch is not much better. It's only 109 pixels per inch, even though it's a new, modern, fancy screen. Okay. That's not the case for smartphones, mobile devices. The original iPhone had quite a... This is not the Retina iPhone, not the big fancy iPhone. This is the original iPhone, the very first one that came out. It had a much higher resolution of 163 pixels per inch. But that really wasn't, that's not the Retina display. The Retina display came out most recently, or really first in 2010, with the iPhone 4 and then also the Google Nexus S. Those two displays have more than 300 pixels per inch. That's more than 3 times the display of that 2002 monitor. It's 3 times the display of a brand new iMac that sits on your desktop. 300 pixels per inch, that's huge. That's approaching the resolution of ink on paper, of like a laser printer, or of the kind of resolution that your eye can detect. That's why when you look at these screens up close, you can barely, if you really, really try, and see the dots, because about 300 dots per inch is where the eye at normal reading distances can stop seeing the individual dots and just see the image. Very cool. What it means is that if you were to take the letter A and look at it on a microscope on a regular computer monitor, a laptop or desktop or on one of those old CRTs, it looks something like this at 100 pixels per inch. But a 300 pixel per inch display is much, much smoother. Looks something like this. Now, this is not only true of smartphones, and it's certainly not only true of Apple smartphones. But in terms of smartphones, a laptop just came out, the MacBook Pro, that's got a Retina display, and it's 220 pixels per inch. Now, interestingly, this display is not as sharp or as high resolution as the display on the smartphones, on the iPhone 4 or on the Google Nexus S, but it is still higher than a traditional laptop or desktop, and so it's called a Retina display. By the way, this term Retina, it's marketing speak for high resolution. It's made up by Apple. So the Google phone has a high resolution display, but they don't call it a Retina display because that's a word that Apple made up. And Windows, and Apple's not the only company that's doing this stuff, and they're not the only company that's going to be doing this stuff. You will very soon see more and more smartphones and tablets, laptops and desktops soon that will have these high resolution displays, and they'll be produced by Apple, and there'll be ones that have Windows on them. So this stuff is not going away, and it is a trend by which folks can sell new computers, new smartphones, new tablets, and take all of our money. So unfortunately, this is not something I think that's going to be a flash in the pan. This is something that's going to be significant and long lasting. Okay, big idea number 2. If you are developing web pages that are going to be seen by high-resolution displays, which is all of us, by the way, we're all developing web pages that are going to be seen by high-resolution displays, then you don't have to worry about typography or CSS elements. Another thing you don't have to worry about is layout. Browsers take care of layout just fine. They'll render your page normally all on its own. But let me get back to type and CSS elements. Type renders absolutely fine. Here's an example of a screenshot, or here is a screenshot. On the left, a web page is viewed on a laptop, on a traditional laptop, and on the right, viewed on a high-resolution display. So the layout is exactly the same. And the reason the layout is the same, by the way, the folks who made this website did not do anything special to account for high-res displays. So this is the exact same code, just viewed on 2 different displays and with nothing special or fancy going on. You see the type is rendered much more smoothly here on the high-res display. The photograph looks about the same. Things like these dots, this is a CSS effect, a border effect, look the same. And the layout looks the same. So in terms of text and layout, you don't have to do a thing, and the text will look sharper and better on high-resolution displays. Here's another example provided by Apple. They have this on their website to show the difference between the old iPhone, which had a high-resolution display but not Retina. That was the, I think, 150 pixels per inch. And then the new iPhone that's got the 300 pixel per inch fancy display. And they're demonstrating here on a sample New York Times homepage the difference in type here between this headline and this headline. Pretty dramatic type difference. Now, the New York Times has actually done a lot of things to their homepage to make it look better on high-res displays, but this is not one of them. This example that I'm showing here is not something fancy or special going on. The type just looks sharper on these high-res displays because the phone is taking care of it. The browser and the operating system are taking care of it. The New York Times doesn't have to do anything. So type renders fine on high-res displays, and you don't have to do a thing as a developer to make that happen. CSS properties also render fine on high-res displays, and you don't have to do anything to make them happen specially. Let me go through what those CSS properties are. I'm talking about colors, I'm talking about borders, border radius, which are curved borders, gradients, and shadows. Basically anything that does not rely on an image, a PNG or a GIF or a JPEG, anything that doesn't rely on an image that uses CSS will render fine on high-res displays. Let me walk you through this. Here's an example from last week's webinar where we created forms, and this is the homework assignment. This is the finished version of the homework assignment. It's got some form fields, and it's got a button down here that's rendered entirely in CSS. The curved borders here, the gradient in the background, it's got a shadow on the button, and it's got a shadow on the text. All that's done in CSS. If you look at that on a 100 pixel per inch monitor, which means a traditional laptop or desktop display, it's gonna, and you put it under a microscope, it's gonna look something like this. It's a little jagged around the edges and the text renders like this. Now this is what we're all used to. This is completely normal for desktop and laptop displays. Nothing is wrong here. However, on a 300 pixel per inch monitor, it's going to render a whole lot sharper because that's what the monitor can do. All this stuff renders sharper automatically without you having to do a thing because it's all done in CSS. Does that make sense? Because CSS renders fine at any size, some folks, as a sort of a side note, some folks have done a cool thing with this. They said, well, hey, let's use CSS to make shapes. And they've actually, I'm going to show you some cool stuff. It's a little side note, but it's really cool. Okay, so how do you do shapes with CSS? I'll show you. Doing a square with CSS would be ridiculously easy. Here's an example of a square with CSS. It's a div or any other block level element. It's got a width and a height assigned to it and a background color assigned to it. Boom, you've got a square. No problem, right? Okay. You could do the same thing by manipulating, you could do the same thing, but manipulate the border radius, the curved border. And if you manipulate the border radius such that it's actually a full half of the size of that square, it turns it into a circle. So you can create a circle out of a div or any other block level element simply by specifying a width and a height, a background color, and specifying a radius that's half the width and height. So cool. This code, by the way, is here at this website. It's called it's in csstricks.com. I am including the code, the URL to this example and to all the examples that I'm showing here in the forum post that will be on thesummeroflearning.com after this webinar is over. So if you don't get to write this down, don't sweat it. The slides are available online. All this stuff will be available online. So you can make a circle in your CSS, in your web page without having to use any images at all, just by manipulating the border radius in this interesting way. Likewise, you can make triangles by manipulating the distance of the thickness of the borders. It's the way that borders are drawn in CSS is such a way that if you make the border half of what you want that length to be, it renders it diagonally. So you can make triangles. In this case, it's a triangle that points up. Some folks some fun nerds who are smarter than you and me have put together a list of a bunch of different shapes that can be created purely with CSS and purely using one block element. It's really cool. And these shapes are available online. You can get the code online. You can copy and paste it and use it in your web page. And you can use it in the homework assignment you're going to get. And it works fine. In old browsers it doesn't work, but something like this you're not using because you want it to work in all browsers. You're doing it because it's interesting and dorky, and if it works in new browsers, great, and if it doesn't work in old browsers, great. So I'm not suggesting this as a bulletproof way to handle these kinds of problems, but I'm saying it's very interesting. Some folks have taken this a step farther and used CSS gradients to create patterns. So all of these patterns that you're seeing here and a bunch more are created entirely with CSS. There's no image involved at all. The sizes of these are very small. For instance, this bricks image is only 354 bytes. That's bytes. That's a third of a kilobyte to make that image, to make that pattern, and these tile beautifully. So I think they're pretty cool and interesting, and the link's down here and on the forum board. My point here is that type and CSS, as long as it doesn't rely on an image, is perfectly fine on a high-res display. You don't have to do a thing. Okay. So what about images and graphics? Well, if you want to use images and graphics on your web page and you want them to look good on Retina displays, you got to double the size. I'm going to explain what I mean by that, and I'm going to show you examples of how it does and doesn't look good. Let's take something like this. This is something, a little snippet off of a web page, a little screenshot that you would probably have to put something like this on a client's page, or I know I have. It's a little icon next to a piece of text. In this case, it's a word bubble next to "What do you think?" and it might be the header for a section of comments on the bottom of a web page. If you were putting something like this together, this would be, you could do it a number of different ways. How I would do it is I'd make this a block level element like a H3 or an H4. I'd have the text of that element be here, and then I'd shove that text over using padding and let that be a background image for the element. It'd be a PNG, or if I was going old school or I needed it to be animated, a GIF. So a background image ping and text and an element, totally normal. A very, very standard way of doing this. Well, let's see what this looks like on a traditional display, a traditional laptop or desktop display at 100 pixels per inch. It looks like this. Now, it's going to look completely normal, completely natural, and that's what the display can show. On a 300 pixel per inch display or a high-res display, it's going to look like this. See the difference here? The text renders nicely. Because text, it upscales to that high-res display automatically. However, the image does not. This is just a PNG or a GIF. So there's no way for the browser to be able to scale that up and make it look nicer at the higher resolution. And it looks icky. The reason it looks icky is because you've got something that's really sharp next to something that's really fuzzy. If they were both fuzzy, it looks normal. It doesn't bother us at all. But if it's not, it looks icky. So how do we deal with that? Let's take the image that I used to create that little bubble icon, bubble.png. It's the size, it's created at the size that I would normally show that little icon. To solve this problem, I also have to create a second bubble image. I'm going to call it bubble at 2x.png. It's the same as bubble.png, it's just twice as big. Now, in order to make an image twice as big, of course, I have to have the original Illustrator file, or I have to have something that will let me blow it up. If I'm just trying to blow up an image and I don't have vector graphics around it, it's just going to look pixelated and it doesn't do anything, it won't help me at all. But in this case, I do have the original vector file, and I was able to make a double-sized image. I gave it a different file name. I happened to give it this file name. The @ sign is completely legitimate to have in a file name, by the way. It's bubble @2x.png, and it's saying, okay, it's bubble at twice the size. That @2x I'm going to come back to in a minute. Then, if I've got these two images, I upload them to the server, and I have to get high-resolution displays to use the bigger of the two images. Here's how I do that. So, if I've got this comment, that's got a background image of this bubble.png. Now, of course, there's going to be other CSS involved here, like, for instance, padding to shove this guy over. You want to have it not repeat. I've omitted all the rest of the CSS that's required to actually display this for brevity and to show less on this particular slide. But the relevant thing here is that I've got a background that's this image, the bubble.png, and that's what's showing up here. What I need to do is to somehow say, hey, high-res displays, do this thing instead. For that same element, which I've given an ID of comment, give it a background image of that other one, the one that's twice the size. Now, if I do that, of course, if I make it twice the size, that bubble is going to end up being twice as big. So it would be something like this big. Oops. It would be something like this big instead of the size it is now. So I have to use the background-size attribute, which changes the size of the background image, and I make it the size that I want that bubble to be. The background size declaration takes two parameters. The first is the width and the second is the height. I'm saying make that bubble 20 pixels wide and make it whatever height it naturally falls at. It's just my little shortcut so I don't have to figure out what the height is and type it in there. If I didn't do that, it would stretch it. It might make it look icky. So this code right here, I only want to deliver to high resolution displays. I could deliver it to everybody, honestly. I really could, except then everybody would get the big version and it would take longer to download. And some older browsers don't handle background size very well. Ironically, those older browsers, they're not going to have high-res displays anyway, so we're not going to worry about those for them. But we do want to have this stuff only show for high-res displays. We could do this with JavaScript, but there's a CSS way to do it. The CSS way to do it requires that we first ask the question, how do we determine whether this resolution is high res or not. The question that CSS asks is how many more pixels are available than the standard number of pixels. The answer to that question is in CSS called the resolution or the device pixel ratio. These are fancy words for saying how many more pixels than normal does this display have. This is a number. These two things are numbers for each individual display. For a smartphone or for an iPad or for a laptop, they're going to return a number. That number key is something like this. If the number it returns is 1, then it's normal. It's a regular display like a desktop or a laptop at about 100 pixels per inch. 1.5 is pretty high resolution. There's certain smartphones that fit in this category. 2 is very high res, like the new iPhone, the iPhone 4. And the Nexus S. And there's not a 3 yet, but it could go on to 3, 4, 5, and so forth. Right now, we're at about 2. That's the highest resolution displays are at about 2. So let's bring this back to the CSS. What we need to say is something like this. We use the @media declaration, which is specifically in CSS a way to target CSS to specific devices or media. And we say, I need the minimum resolution to be 1.5, this is crazy, dots per pixel. 1.5 dots per pixel. That targets these guys. Anything more than 1.5, so it gets the pretty high res, the high res, and it even gets into the future. We said anything over 1.5 dots per pixel, so that's pretty high res, should get the bigger version and scale it down. Anything that's less than 1.5 sticks with this. That's what's going on here. Now, this older browsers will ignore this, and they will ignore everything inside this. So you're okay on older browsers. They'll see this, and they won't see this. Now, it's not quite as simple as this, but this is pretty much how simple it is. When I say it's not quite as simple as this is what I mean. This declaration here, min resolution, is the standard, but nobody's actually using it yet. So we've got to use browser hacks. They're not that onerous, but the real way to do this practically today is an @media query that looks something like this. It's @media, and you've got min resolution, this thing that we had before. But you also have to add a version for WebKit, which is Apple devices, and actually Google devices. It uses Chrome and Safari, for Opera, and for Firefox. These are the three for those three kinds of browsers, and the standard one, which should be supported well in the future. So anything in between these curly braces is going to go to high-res displays. Now, before you try to write this down furiously as you're on this webinar, I've copied and pasted this. It's in the forum board posting so that you can have a permanent record of it. It's also all over the internet. I did not make this up. It's sort of a standard way of handling high-resolution screens that works cross-browser and cross-platform on a bunch of different devices. It's fairly complex, but you copy and paste it, put the CSS in here that you want to use to target high-res devices, and you're good to go. A lot of work, huh? But this is the result. On 100 pixel per inch screens, you get this, which is completely normal for them, and on high-res screens, you get this. So it looks great for everybody, depending on what screen they're on. Does that make sense? You can use this on any content management system, doesn't make any difference at all. This is all about using raw CSS to solve this problem of high resolution screens and delivering images specifically to those screens. Now, I made two different bubble images, bubble.png and the double-sized one, bubble@2x.png. The file name here, the @2x.png, makes no difference at all what that file name is. Could have just as easily been bubblebig.png or your mom. It doesn't matter. What matters is that you refer to it in the CSS properly as the double resolution image. The bubble@2x.png, that's a standard that Apple came up with, and they said for their images, they would like to see them @2x.png, and that's just the style that they're using. There's no technical requirement around it at all. You can name it anything you want, but because Apple set this standard, a lot of folks are using it, and without some other naming convention, I'm fine with it too, so that's what I use. Does that make sense? Great. Now, let's move from CSS background images to foreground images, IMGs. Let's take this picture of a kitty. Oh, cute kitty. On a traditional laptop display, it's going to look like this. On a high-res display, it's going to look exactly the same because that's all the pixels it has. So if you want to make a high-res display look better than a low-res display, you do the same technique. You have two versions of the kitty image, the low and the high-res. That way, the low-res display looks good for the low-res folks, and the high-res display looks good for the high-res folks. So how do you display this image, this double-sized image? Well, it's not a background image, so you can't use a CSS query to do that the same way you could with a background image. Two methods. Method number one, you serve the high-resolution image to everybody, so everybody gets the high-res. Here's how. You would take your double-sized image, the kitty image, and you would apply width and height tags attributes to the image tag, or really you do it with CSS. I'm doing it the quick and dirty way. If you're doing it nicely, you're going to do it with CSS, not with these ugly attribute tags right in the image tag. That shrinks it down to the size of the original kitty image. Browsers can handle this pretty well. They did not used to be able to make it look good if you shrunk an image down in the browser, but now they can. Now, if you're smart, you'll say, yes, but that means I'm delivering a bigger image to everybody, and all my pages will take longer to download. And yes, that's true, but not all the time. Let's take the example of the kitty. This kitty picture, the original kitty picture, this is the actual one right here. I dragged the JPEG into this presentation. This is the full size of this kitty image. I saved it as a JPEG of 51 out of Photoshop, and it's 31 kilobytes. Then I took the big kitty image, the double one. Here it is, scaled down, but I crunched the heck out of it. I saved it as JPEG quality 5 because most people are going to see it crunched down at half the size. So I could really compress the living daylights out of it, and I actually got it smaller at 29 kilobytes than the original at half the resolution. Crazy, right? But it's because we're looking at it at half size. Now, if an iPhone user zooms in, they're going to see JPEG artifacts, and it might look a little bit icky. But there are ways to compensate for some of the file size issues. Second way to show images to a user, high-resolution images, is using fancy JavaScript. You can roll your own, or you can use something like this one, Retina.js, that magically grabs all the images on your web page and looks for high-resolution versions. If the high-resolution versions are available, and if the user is on a high-res display, it shows them instead, does it all for you. That's images. Both graphics and photographs work the same way, whether it's a PNG, a GIF, or a JPEG, and those are the ways that you handle an IMG image and a background image handled through CSS. Let's move on to vector graphics. You can put vector graphics on a web page. There are two different ways to do it, SVG and fonts. Let me walk through those. When I say vector graphics, I'm specifically talking about things like icons, I'm talking about logos, I'm talking about anything that is a drawing that you would like to present on the page. That word bubble earlier would be a fine example of that. So SVG and fonts, two ways to do it. SVG, Scalable Vector Graphics. It's like Adobe Illustrator for the web, kind of. It's a way to show files like Illustrator files on the web natively in your browser, and they look great. And SVG is dirt simple to make. You open up an image in Illustrator, a vector graphics file in Illustrator, and you'd basically do a save as, and you've got an SVG. You embed that on your web page, and lickety split, you've got your logo taken care of. Gradients generally work, all the colors work, layers that, it smushes them all together because you can't actually edit it on a web page. But SVG is beautiful and so simple, and takes care of putting vector graphics on your web pages for you, except that it doesn't work everywhere. This is a chart of where SVG works. The green means it works, the red means it doesn't. So Firefox, Chrome, Safari, Opera, all these guys use SVG perfectly, no problem at all. Here's the killer, Internet Explorer. Everything up until Internet Explorer 9 does not know how to handle SVG. Moreover, the Android browser, older versions of Android, which a lot of people are still using, also can't handle SVG. For most folks, that's enough to take SVG right off the table. If it doesn't work in IE 8 or below, you can't use it because so many folks are in Internet Explorer and so many folks are still on those old versions. Now, there are some polyfills, there are some ways to handle SVG on those old browsers. One of them converts SVG into Flash. It doesn't work wonderfully on the Android versions of that, though. So SVG is one of those things that we're going to really look forward to, but in my opinion, it's not ready for wide-scale use yet. So that leaves the second method for inputting vector graphics on a web page without converting them into rasters or pings, and that is fonts. Using @FontFace, the CSS technique for embedding typefaces on a web page, using CSS fonts to show graphics. That's interesting. Let me show you how. We've all seen typefaces. In fact, if you've got one with your Windows or your Mac machine, that's a Dingbats typeface. It looks something like this. This is one called Pictos. It's free and available. But you've got one on your machine, Zap Dingbats or something like it. And you load it up and you type the letter, you type the letter K, and instead of getting the letter K, you actually get this little symbol of a key, right? So why not embed that font on a web page using @FontFace? And then, when you want to show the key, just type the letter K. Hey, it works great, actually. It works fantastically. And it works so well that a number of typeface makers have created fonts specifically meant for web use. This Pictos is one of them. Here's another one called Font Awesome. It's made by the folks who are in Twitter and make the Twitter Bootstrap framework. But these icons are specifically meant for web use. And there are these and many more. They come as a font, and these guys, the Font Awesome guys, do some really cool trickery, JavaScript trickery and CSS trickery to make it work on screen readers and for SEO, and you show the fonts, and it works in old browsers, and it's very cool. But really, all you need is a typeface that you load onto a web page. So some of you might say, well, hey, if all it is a typeface that lets me put in any of these vector graphics, why not just make your own font? Well, yeah. It's absolutely right. It's exactly what you can and should do. You can take your company's logo, for instance, and you can take it out of Illustrator, copy and paste it into a font program, and make your own custom typeface. And that typeface only needs one letter, if you've only got one graphic, or 2 letters if you have 2 graphics. It makes it nice and small. You can embed it on your web page and show it at any size you want. And it works, except a couple of caveats. First, you can only use one color. Just like a letter can only be one color, so can a pictogram that uses typography. So if you have a logo or you have a graphic that needs to have multiple colors, you're up a creek. Or, there are some hacks and some ways around it, but you're starting to get into tricky territory, and it's not the easiest thing in the world to do. The second caveat is that font software generally is expensive or difficult to use. You can choose one or the other. It's either incredibly pricey or real pain. I'm not talking just a little pain. I'm talking a real pain. And that was actually very true until just recently. And finally, one of these font makers came out with a piece of software that wasn't $700. And I'm going to tell you about it right now because I just found out about it myself, and I'm really excited about it. It's this program called Glyphs. They make a version that's $700. That's the full for making big typefaces. fully feature typefaces, and they make a mini version that's $50. The $50 version is specifically geared towards folks like you and I who are making web fonts out of graphics and want to display them on web pages. There's also a free version of this kind of software. It's called FontForge. It's a real pain to install and use. The interface looks like it's from 1972. You probably have to compile it for your Mac. There are some binary packages, but they're tricky. So it's free, but you get what you pay for. Last thing, and then we'll take a couple questions. How do you test your web pages on high-res displays? Is there some sort of simulator that you can use, or some sort of a way to see how it's going to look? Unfortunately, there's not. You have to actually get a high-res display in order to see how things are going to look on high-res displays. You can check the layout using simulators like the iOS simulator that comes with Xcode that Apple provides, but you can't check whether the high-resness is working or not. And unfortunately, that means that if you're a large, very customer-focused website that has a lot of different mobile devices coming to it, your desk may end up looking something like this. But there's not another good way around it, unfortunately. I wish there was, but there's not, because your display has to show, it's your monitor that you're talking about here, so it's hard to see whether it's high res or not if your monitor can't display at high res. This may change in the future, but right now that seems to be the state of things. That's it for the presentation. I'm going to give you some homework. Here's the homework assignments posted to the forum board. It's a page. It's in honor of the elections coming up. It's a web page that we've made up for you that looks something like this. It's got pictures of the two candidates and various CSS trickeries happening. You need to recreate it and make it look good on low-res displays and on high-res displays. I'm talking about things like, oh goodness, let's come back to that. I'm talking about things like this up here. This is a circle that's created with CSS with a background image that's tiling, and you'll need to make it look good on high-res displays. These images need to look good if you're on a high-res display. And this button down here with this little talk bubble needs to look good on high-res displays. We've included all of the assets that you'll need to put this together, including the photographs, including all the graphics and the images, and we've included a solution if you get stuck. When you're done with this homework assignment, post your work in the forum. I'd love to see it. I'd love to give you comments on it, give you feedback on it if we can, and especially so that you can give each other comments and feedback. That forum is developing into a nice place where folks are talking to each other and making connections, and that's really fun to watch. It's really cool to see. I hope that you'll join in on that. Thank you very much for your time. I really appreciate it. We've got a little bit of time left. I'd like to take some of your questions if there are specific questions that folks have. I've got Kevin here with me. He's been monitoring all of your questions. He's going to filter a couple up to me.
Jim, one of the questions that came up repeatedly was what to do with web fonts. Is there something special that we need to do with web fonts to optimize those for high-res displays?
Any web font will look good on high-res displays no matter what, because fonts themselves are vector. So the browser takes care of it. Anything that has to do with typography looks good on the normal display, on high-res displays, and the layout is identical, so you don't even have to worry about it reflowing differently. Everything's taken care of for you by the operating system and by the browser. Great question.
Jim, can't we just serve up images instead of saving them at, the usual 72 DPI? Can't we just save images at 300 DPI and serve those up instead?
Oh man, I love this question. This is a great question. The key factor when you're saving images for the web is not the dots per inch. I know I've talked ad nauseum in this particular webinar about pixels per inch for the display on a monitor, but it's not the same thing when you're saving an image. What matters when you're saving an image is the number of pixels. So if you need an image to be a certain size, like say 350 pixels wide, it makes no difference whether it's 72 pixels per inch or 300 pixels per inch, because it's still just 300 pixels. So that's the thing when you're making images for the web. Pixels per inch or dots per inch of that JPEG itself, of the image itself, or a GIF or a PNG, the DPI makes no difference at all. You've got to actually double the number of pixels. It's real confusing, and it's tough for print folks to get around because in print, get their head around because in print the DPI matters hugely. but on the web, only pixels matter. Thanks again. Have a great rest of your day, and talk to you soon.